Okay, continuing on. I think 1.3 is fine. We don't really need any manipulatives for this, and we have problems set up like this. Again, we have videos, or we have MathAS problems for this. I'm not thrilled with how either they have to put the zeros or we made it that they don't have to put. So if this was a smaller number like 5003, first they had to put all the zeros in, then we made it that they don't, but there were all these empty spaces they just got credit for. I don't know if there could be a better way to do that, but it's working, so it's not a big deal. Don't need anything for that. You have a manipulative where they put the numbers in the chart, or the numbers come in the place value chart and they sort them up and down, so this is good. I have a thought on rounding numbers, but not really. Here are the more important ones. So adding and subtracting whole numbers using base blocks. Okay, so let's go to the NLVM site. Okay, so I will create a problem. So I like how they set this up in terms of they have two separate places. This is for the first number, this is for the second number. So 111. This is kind of a pain, and you kind of run out of space. Oh, I want there to be 10 of something somewhere. 1, 2, 3, 4, 5, 6, 7, 8, 9. Put some of those down there. I think there's more than 10. Okay, and I guess we could start with one where they don't have to regroup anything. And they're just thinking of combining and counting them. Okay, I'll hit begin problem. So they set up the problem. I guess we could have one where they set it up, or we just give them something like this and show this representation here. So it's 175 plus 231. And maybe they fill in these components, but we don't let them fill it in until they've regrouped it. So here, it doesn't show the 6 here until we've regrouped the tens place. Okay, so there's exactly 10. Ooh. We lasso, it turns into the next place value. Notice 5 and 1 is 6. 7 and 3, they didn't put the 0 because I need to carry it over. Then we have the 0, the 1 carrying, and the 4. Okay, and this is kind of fancy. I don't know if we need all of this. And what I'd like them to see, in addition to the regrouping that we just did there on some of them, okay, is that this is the action of combining. So the two numbers are separate, and they're separated by this line, but when we have the addition, we think of it, we have combined these sets, and now we're looking at them all together. So I'm not quite sure how we can do this, except, we start off with this line where the two are represented separately, and then maybe when we combine them, I don't know, if the line just disappears, they might not notice that the line has disappeared. Maybe there's some sort of grouping process where you see them line up into one group instead of the two separate groups, and then they start regrouping from there. Okay, I think you'll have a better idea, Bill, of how you might be able to do this. Okay, let's look at a subtraction one. Now remember, there's definitely something I don't like about the subtraction. Just because we're dealing with whole numbers, so here they have 13 minus 8. Again, they have, the two lines separating. So the way they do this is kind of a cancel out model, and this reminds me of integer chips, which is great, except we're in whole numbers, and we're really focused on, we use both the takeaway and the comparison model. So to me, this is Yeah, this is more integer chippy. So what I'd rather see for something like this is you give them the first number. I wouldn't give them this. They need to take away 8. Okay, so maybe there's a takeaway bin. So maybe there's some sort of bin here, but a large one where you can see what they take away. They have like a little garbage can where you can put stuff in. But so start here. Now there's a takeaway bin. They'd have to decompose this 10 into 10 ones, and then there'd be some spot labeled where they could still see it. Oh, it's not going to let me put it over there because it's a different place value, where they'd drag the 8 that they're taking away. And once they've 2, 4, 6, 8, and once they've dragged them into that bin, then maybe the result shows, or maybe the takeaway bin is counting what's in there as well. Okay, and then they can know when they're done taking away, and then they would count this end result of 1, 2, 3, 4, 5. Yep, that seems to line up. So for takeaway, just again thinking of starting with some original amount, and then they have a place where they have to put what they're taking away so we could see that value. Okay, and then the result is what's left over. You might want to start with one where they don't have to decompose anything, and then another type where they do have to decompose, and take 100 and make it tens, or make tens ones. Okay. The other type we could have is we talk about the comparison model. Okay, and the comparison model is different from this. So what they do here is they just have them cancel out. Okay, and again, this isn't bad, but this just isn't the model we use. So with the comparison model, we think of starting with the second number. So you'd start with 188, and you want to add on something or some amounts to make 188 look like 237. Okay. So maybe you'd have this in the upper left corner as the goal. They're starting with 188. So what would they have to add? Well, here to get a rod, or to get a flat, they would need to add 2 more. Oh, it's not going to let me do that, but so I'll just kind of explain the idea. And maybe it would be in a different color, not red or blue. Okay, so they'd add 2 greens, and that would give them, they could group this into a flat that's 100. And then they'd need to add 3 more greens to get the 30. And then they'd have 8, and they need to get 7. I wouldn't like that at all, because they'd have an extra red one. Maybe we'd have to contrive the comparison ones a little bit more specifically so it wouldn't be as messy as this. And I'm not completely sure we need one, so moral of the story, don't worry much about that. Okay, so I think that's addition and subtraction as far as base blocks. As far as number lines, you made some number line ones. I think it's more of a proof of concept, so you have smaller numbers like 3 plus 7. We might want ones with bigger numbers. Okay, but I think for addition and subtraction of whole numbers, that's good.